Hi everyone, my name is Thomas Kim. Today is May 17th, 2019. This is my 14th episode about the future of C++ programming, C++ 2A standard. In this episode, we will learn about the consequences of exception leaks from the C++ constructors. Most people or most professional tutors or C++ language experts says we should never leak exceptions from the C++ constructors. But most exceptions, serious exceptions, occurs while initialization process, and this initialization process is carried out most of time in C++ constructor. If initialization fails and we cannot throw exceptions, there is only one fate. The fate of our program is to crash. For our mission critical application crash is not allowed. So how to cope with exception leaks from the constructors? If we understand the consequence of exception leaks from the C++ constructor, then we can cope with such exceptional situations. In this episode, we will learn the consequences of the exception leaks from the C++ constructor such that we can prepare ourselves for exceptional situations. If we understand correctly the consequence of exception leaks from the C++ constructor, our application can cope with the exceptional situations. To follow this episode, please watch this video or double-click this link. From this video, click Show More, click this button to download our source code. We will be using some source code from this application. Show in folder, unzip it, double-click, copy this file, copy. In our working folder, create a folder, exception leaks from constructors. Paste in this folder. Copy the folder path, start your Visual Studio Code, file, open folder, paste. Also right-click your command prompt, right-click, paste here, Ctrl-A, Ctrl-V, click OK. In this folder, create exception leak, CPP. Ctrl-V, I will close this, include memory leak detect, include IO stream, we first need to have concrete understanding about the initialization sequence of member data or base class. For this purpose, class member field. I create a class, don't forget semicolon here, private. I will include the string, from private std string m member, public. I will copy this member field constructor. I will create a constructor, constant character pointer, name, m member, name, then here std cout member field, this is constructor, is called. Now I copy this function, copied, pasted. I will change here, and this should be this member. For is called, and I will copy this again, this line. I copied and pasted it here. Now this is destructor. I will mark like this. This is destructor for member is called. Okay. So now I create a class initialization test class. Here private, I create two member here, member field here, member A, member field, member B, public. Now I create initialization class here, test class, I copy this, I initialize with B, then here I put B like this. This is called initialization list. I copy once again. This is A. Now this is constructor body. Of course, it requires parentheses here. std cout. I copy this. Is called now I copy once again, paste. This is destructor. So here I remove destructor is called. Okay, so we created a member field class like this, and this is constructor, and this is initialization test class, has two data member fields, two data member fields, and A is declared first, then comes B, but this is initialization list. Here B is called first. This member is initialized first, and then we initialize this member. Okay, then this is function body, initialize constructors function body is called, then this is initialization test class destructor is called. We have to note the initialization of member A and member B very carefully. So here void example for initialization sequence. Here int main. Now I copy this function and paste it here. At this point, we construct an element, an object here, my obj. Okay, so we are constructing this instance, my obj. Now we compile it. Start your command prompt, dir cl. We are using Microsoft compiler EHSC. We will use std C++17 exception leak cpp fe aexe. This is Microsoft case 21. So it should be destructor. Please note that this is destructor. And let's compile once again. CLS. So we are running A. Please note that, please watch carefully. Here, even though in initialization list we called member B first, we initialized member P first, but member A is called first. Okay, member field for A is called. This constructor is called. Even though we initialized B first, member B first, this member is called first. And so please note that member field for A is called first. This initialization is called first. Now we swap the order. We change the order. Cut. Paste. I changed the order. Now here we build once again CLS A. Now B is called first. Because B is declared before member A. Okay, so this initialization list does not define sequence. The sequence of member initialization list does not play anything about the order of initialization or member initializations. The sequence of member initialization list, this is the sequence of member initialization list, does not play anything about or does not contribute anything about the order of member initialization. Okay, the member initialization sequence or order is governed by the order of the declaration of the member declaration. Okay, now I hope you understand this concept. This concept actually plays very important role. Okay, so I will restore it back, copy, paste. So always initialize in the sequence of declaration, member declaration. So So always initialize members in the order of declaration. Okay, like this. This is very important. I will explain why it can play important like this. Now here, class out of order. I declared a class out of order. Here, public intm a intm b out of order initialization. Let's see what it means. int a int b. Okay, we initialize b first. We initialize b first like this. We initialize b, then initialize a. We say mb plus 1 like this. We initialize b first, then using mv we initialize a like this. Okay, this does not work as you expected. This does not work as you expect. Okay, I will explain shortly. Now I make a function consequence of out of order initialization. So I copy this, paste out of order initialization. I initialize 1, 2. Okay, so in this case we expect b is initialized first, so 2 is initialized. mb will be 2, and the value of mb2 is added with a. Okay, as in the initialization list, b is initialized. mb is initialized with 2. ma is initialized mb, in this case 2 plus 1, it is value 2, so it should be 3. We are expecting like this, but it is wrong. But it is wrong. Now let's try out std cout ma ma std, and then copy once again mb. So mb, now let's try it. Copy, paste it here. Now we build and run. Voila. Here we initialize the b is initialized 2, but a is some strange value. Why? because this A is initialized, MA is initialized before MB. Okay, so in this case MB has garbage value. MB has garbage value plus A is garbage value. Okay, so it is incorrect. If you want to make it fixed, then you have to change the order. If you want to fix this, you have to change the order like this. Okay, if we change the order, then it works as expected. So it works as expected. So this init declaration, the order of declaration, the order of the member declaration terminates the order of initialization. Okay, initialization list does not contribute to the order of member initialization list. I hope you understand. Now we will do another experiment. Now let's talk about base class initialization. I will include type trace here. Include type trace. I included type trace. This is for std. Is the same value type function. Here, right before function main, template, type name type, class, tmp base. Okay, I created a tmp base, template base class, public. I create a constructor like this. If context here, this is introduced in C++ 17 standard, std is the same value. Okay, if type is int, else if context here double, I copied and pasted. This is for type is double. Now I paste it here, std cout tmp base int is called. Okay, I copy this statement, pasted it here. This is double. Else I copy this and paste. We do not know what type is type. So I made a constructor like this. Now I copy once again, paste. This is destructor like this. So this is destructor, and this is destructor. This is destructor. So this is base class, tmp base class, template, type name, base, base A, type name, base B. class Mixin. I would say Mixin public base A public base B. This is called base class declaration list. Okay, public. I will copy this function, paste, std cout Mixin is called. What we are interested in is initialization process. Mixin. This is destructor is called. This is destructor. Now we are initializing this base class like this. Base A, base B. Instead of doing this, I will modify the change. I will change the order like this. This is base initialization list. Base class initialization list. Okay. We have to notice which constructor A or base TMP base is called, or base B is called first. We have to pay attention to which base class constructor is called first. Okay, we have to pay attention to order of these base class initialization order. Okay, about this kind of programming technique, we pass parameter, template parameter, then use the template parameter as base class. This method is called Mixin. Okay, so you can learn more about Mixin here. I will paste it here for your reference. Okay, if you click it, you can learn more about Mixin technique in object-oriented programming. Okay, keep going. From here, I will create void which base class constructor called first. I would say base constructor base class initialization order. Base class initialization sequence. Okay. Then I will copy this, paste it here. I disable it. Now we call like this, Mixin TMP base. We will call int first, int TEMP base double. Okay, MX. Now build. We are building Clang compiler CLS A. Now let's see. We declare the base A first, base B second. Okay, but in the initialization list, base class initialization list, we call the base B first. then comes base A. But if we examine the displayed code, int tmp base int is called first because we called int first. Int is base A, double is base B, this template parameter. But when we initialize base B first, but the result is base A first. This is int is base A. tmp base int is base A. So this base class initialization list does not contribute to the order of initialization. Base class initialization list does not contribute to the order of the base class initialization list. Okay? Even if we modify, we change the order. So here, this base class declaration, the order of base class declaration dominates the order of initialization of the base classes. Correctly understanding initialization sequence is crucial for successful C++ programming. Correct understanding of initialization sequence is crucial for successful C++ programming. Now, another very important thing here, class base. Public base std cout base is called. This is destructor base. I will copy this destructor called here, class derived public base. Here, public. Now, private. We will use this class member field. I will copy it. Member field m member, and here in derived. Now let's see which is called. Base constructor is called first or member constructor is called first. Copy member. We have to provide a name member, and we call base. Okay, std cout derived called. Y is squiggle. this is constructor. Now destructor, I copy, paste. This is destructor. Derived. Which constructor called first? Member or base class? Now let's try it. Void test member or base first. I copy derived D. Okay, I copy this function, paste, we start with clang. Voila, base is called first. Okay, this initialization sequence, the order of the initialization list does not contribute to the order of the initialization. Base class is initialized prior to the member fields. Okay, now let's summarize. Initialization list, the order of the initialization list does not contribute to the order of the members and base class initialization. When base and member both exist, base classes are initialized in the order of declaration. In the inheritance list or base class list. When multiple members, data members are declared in the class, the order of the declaration is the order of the initialization. Once again, the initialization list in the constructor does not contribute to the order of the member initialization. The order of destruction is the reverse order of the initialization. When base and member both exist, base classes are initialized in the order of declaration in the inheritance list or base class list. Then the member fields are initialized in the order of the declaration in the class. The order of the initialization list does not matter. I originally planned to talk about the consequence of exception leaks from C++ constructor, but without understanding initialization order, actually I cannot talk about consequence of exception leaks from C++ constructor. This session already become too long. I will put label like this, and in my next episode I will talk about consequence of exception leaks from C++ constructor. If you do not understand this episode, you cannot follow my next episode. Please subscribe to my YouTube channel and don't fail to watch